Hi, Corey Shipe here to talk about Polk County landslides that we had in May of 2018 and how we're looking to model some of these hill slope failures. In the background is a Green River. This is in May of 2018 after we received about 25 inches of rain within a 30-day period, 9 inches of which came within a 6-hour period on Friday evening, May 18th of 2018. So here's a photo from the North Carolina Forest Service helicopter that flew after this event. Shows some of the hill slope failures that we had occur, in this case mostly in a kind of a meadow area, not quite forested. These are important for a number of reasons. Unfortunately, we lost 3 folks in these storms. We had a lot of damage both to infrastructure, to homeowners, and just to the general community. So my questions are, can we utilize public remote sensing data to model these failures? And then if the answer is yes, can we actually get to where we're recreating these known failures that we had happen, or we're hindcasting them? The data sets that I'm using are the topography is a primary data set, 6-meter resolution from North Carolina. The 0.5 meter resolution data has been collected for our area of the state. It is not yet released. Our soil data comes on a 250-meter grid from the ISRIC folks. Forestry data comes from on a 30-meter grid based on Landsat 8 imagery. And our rainfall and soil geotechnical parameters are kind of a synthetic or scalar data. These are data sets that we might tweak a little bit to try to get our model to accurately hindcast these failures. What I'm using is called STEP-TRAMM. You can read what it means here. This is put on by the folks at ETH Zurich in Switzerland. We've got a general workflow outlined here, but I'm just going to jump right into the next slide to go through this. Step number 1, we're going to acquire the data. I've split these up into the raster-based data and what I'm calling synthetic data, or the scalar data. And all of these data sets, of course, we need to clip them to our study area. But then we also need to align these rasters, so we need them to be on a common coordinate system, on a common resolution scale, and all the pixels need to line up spatially. The forestry data requires reclassification to get it into a binary function. Is it forested? Is it not? As opposed to what it comes as, which is the percentage of cover. Once these steps are complete, we execute STEP-TRAMM, and then we'll look at the results, refine those inputs, and execute the model again. It is an iterative process with the ultimate hope of modeling these known failures. So I'll jump right into the most challenging steps here. I think we're aligning the rasters and playing around with no data values. It's easy in hindsight, but going through the process, it was pretty difficult from a data management front. The rainfall data in particular in western North Carolina, it is highly variable in the mountains, and so we don't yet have, it's a little bit premature perhaps to just start jumping in with actual data from this area. So my initial effort here was done with simplistic data, just kind of coming up with some rainfall intensities to try to get these hill slopes to fail. From there, we will march toward a more accurate data set that hopefully can do a better job. The results of this, so here are the results on the right, and the top image is the landslide locations. Red indicates a landslide occurred. On the middle plot here, you can see the runout probability. So we have landslides occurring, and then we have runout generating from those landslides. And then the bottom is a soil depth, and so this is calculated based on the reference here shown at the bottom, but it calculates that soil depth. And in western North Carolina, we have failures occur because of our thick soils and heavy rain. So this is all jiving together. Unfortunately, we did not find some of the bigger debris flows. Shown on the left are 2 debris flows that coalesced into a woman's home, and these are the debris flows that caused a fatality. And unfortunately, we have not been able to get there yet, but we are on our way to modeling these types of failures. I think I have a few ideas here of what we can do. So soil depth calculation is done programmatically right now, but we can of course include site-specific soil depth, and I think that'll elucidate a lot of what's going on out here. I spoke about rainfall earlier. Here are a few different sources I'll be running down to get a better site-specific rainfall data set, and then also contacting with the North Carolina Geological Survey to get some better geotechnical soil parameters. So that's what I've got. Shown on the background here is some of the cleanup after these storms. To the left are those large debris flows that were on the previous slide. To the right is the Pacolet River. Thank you very much.